This is Algebra 1, Unit 9, Lesson 2 on irrational numbers. Okay, so first of all, we probably need to know what a rational number is before we do an irrational number. A rational number is any number that can be written as the ratio of two integers. All right, what does the ratio of two integers should look like? It's a fraction. All right, so an integer are two whole numbers, positive or negative, and you can write it as a fraction. So any number that can be written as a fraction is rational. Okay, so these numbers can be written as a fraction are terminating or repeating decimals because they can be written as a fraction. Okay, so let's take a look at some examples of rational numbers. Okay, 1/2 would be a rational number. It's 1 divided by 2. That's a ratio of two integers. It's a fraction. It can be written as a terminating decimal. 1/2 is 0.5. Terminating means the decimal stops. So if the decimal stops, it's a terminating decimal. It's a rational number. Okay, now if I do 2/3, for example, let me grab my calculator and do 2/3. 2 divided by 3, I want to see the decimal form. Notice this is a repeating decimal. So this is 0.66 repeating. All right, so we would write it with a bar over the top. Now the nice thing about repeating decimals is you can make them into a fraction. If you hit math enter on your calculator, it makes the fraction 2/3. So if you can get a repeating decimal, and by repeating I mean it repeats the same thing over and over again, then it's a fraction, or it is rational. Okay, here's the question. What about the number 4? Is that rational? Yes, it is, because 4 can be written as 4/1. So any whole number is rational because it can be written as a fraction. So a rational number can be written as a fraction. It is either a terminating or a repeating decimal. Okay, so that brings us to irrational number. Okay, an irrational number is any number that is not rational. They can't be written as a fraction. Okay? These numbers are called non-terminating and non-repeating decimals. Okay, so let's think about what that means. Terminating means stops. Non-terminating means doesn't stop. And non-repeating means it's repeating over. It's not repeating the same thing over and over again. All right, so we know a very famous irrational number. The very famous irrational number is pi. Pi, or any combination using pi, is going to be irrational. If I put pi in my calculator, if I press second and then the caret key right here, pi is right above it, and I press enter, I get this wild decimal. It's a weird decimal. It's not going to repeat the same thing over and over again. All right, so pi is approximately 3.14159 ... It goes on forever, and the numbers do not repeat. Okay, so if you have any number that does not repeat, so for example, 0.473216 ... Okay, that can't be made into a fraction, then it is irrational. Okay, square roots of non-perfect squares are always. Okay, so if I take a perfect square, so for example, if I did, if I did the square root of 9, the square root of 9 is 3, that's a rational number. But what about a non-perfect square? Let's see what happens with this. Let me do the square root of 2 in my calculator. The square root of 2. I get this number. Can I make it a fraction? Math, enter, enter. No, I can't. Notice the decimals do not repeat. So this is a non-terminating, non-repeating decimal. So the square root of 2 is 1.41421356 ... Okay, let's look at the square root of 10, see if it does the same thing. Square root of 10, I get 3.16227766. Okay, so notice it does not repeat the same thing over and over again. All right, so this is a non-terminating, non-repeating. This is 3.16227766. 566 dot dot dot. And then the square root of 23, you think it's going to be repeating decimal? Let's see if it is. Or non-terminating, non-repeating decimal? Yep, it is. 4.795831523. It does not make a fraction. It does not repeat. So this is 4.795831523. I have this written on a paper in front of me, so I know what it is. Okay, so square roots of non-perfect squares are always going to be irrational. They are non-terminating and non-repeating decimals. All right, so that's what rational and irrational is. Rational can be made into a fraction. They're either terminating or repeating decimals. And irrational numbers cannot be written as a fraction. They are non-terminating and non-repeating decimals. Okay, now let's take a look what happens when we mix rational and irrational numbers. All right, rational and irrational numbers often mix as when we simplify non-perfect squares. All right, let's look at the square root of 28. All right, without using your calculator, between what two consecutive integers will this number lie and why? All right, so what's the closest perfect square to 28? Well, probably 25, the square root of 25. And the next one after that would be the square root of 36. All right, the square root of 25 is 5, and the square root of 36 is 6, and 28 would fall somewhere in between here. Okay, so it's got to fall between 5 and 6. All right, so let me put this in my calculator, the square root of 28, in my calculator. Second square root, 28. And I get this decimal. Is that between 5 and 6? Yes, it is. Okay, so it comes out to be approximately 5.291502622 dot dot dot. All right, now, if I were to put this in simplest radical form, all right, let's see if we can figure out what this is going to be. All right, what perfect square goes into 28? Well, 4 does. It's the square root of 4 times the square root of 7. All right, so square root of 4 is 2 times the square root of 7. Okay, now notice 2 times the square root of 7 is a rational. This part is rational, and this is irrational, and we're multiplying them together. What is 2 times the square root of 7 in simplest radical form? Excuse me, that is simplest radical form. As a decimal, 2 times the square root of 7. If I put it in, it's exactly the same as the square root of 28. Okay, so it should be the same. Yes, it is. Okay, so when you see, this shows us that multiplying a non-zero rational number by an irrational number will always result in an, okay, well, let's see. On this one, the 2, that one is rational. And then the square root of 7 is irrational. All right, so when you say 2 square root of 7, you're actually saying 2 times the square root of 7. So a rational times an irrational gave you what kind of a number? It will result in an irrational number. So an rational times an irrational gives you irrational. All right, so we just did multiplying a rational and irrational. What happens when we add a rational and an irrational number? Well, let's find out. We have 1/2. And we have the square root of 2. This one is rational. This one is irrational. So if I add them together, let's see what kind of number we get. All right, 1/2, alpha y equals 1/2 plus the square root of 2. Okay, and I get 1.914213562. Is that rational or is that irrational? Let me try to make it a fraction. Math, enter, enter. That's irrational. It's a non-terminating, non-repeating decimal. Okay, so let me write this down. 1.914213562 dot dot dot. Okay, 4/3 plus the square root of 10. All right, let's do this one on decimals just so that we have something to show that it does work. So 4/3, 4 divided by 3, and then forward arrow, plus the square root, which is right here, of 10 is 4.956109935. Is that a non-terminating, non-repeating decimal? Yeah, it is. All right, so this is 4.956109994 ... Okay, so again, this part is rational because it's a fraction. This part is irrational. All right, and then we have 7 minus the square root of 8. Let me do that on Desmos again. Clear that one. 7 minus the square root of 8 equals, oops, I hit the wrong button. Sorry. 4.1715279827525. Okay, so you can see that one is also a non-terminating, non-repeating decimal. 5.171572875 ... So if you have a rational added to an irrational or subtracted from an irrational, the result is always going to be irrational. Okay, all right, so let's take a look at the last part. Okay, so now that we know what a rational and irrational number is, let's see if we can figure out if these are rational or irrational. Which one of these is an irrational number? All right, the square root of 25, is that a perfect square? Yes, it is. The square root of 25 is equal to 5. That makes it rational because it can be made into a fraction. Okay, 7 over 2, rational or irrational? Well, it's a fraction, so it's going to be rational because it's a fraction. Okay, and if you do a non-terminating, non-repeating decimal, 7 over 2 is equal to 3.5, which is a terminating decimal. So that one is rational. Okay, 4 minus the square root of 9. Well, 4 minus, what is the square root of 9? It's 3. So 4 minus 3 is 1. That makes it rational. So that means this one has to be irrational because this one is a rational plus an irrational will give me an irrational. If we want to check and make sure, you can grab your calculator or Desmos. 3 plus the square root of 6 is this number, which is an irrational number. It's a non-terminating, non-repeating decimal. So this one is rational plus an irrational will always give you an irrational number. Okay, so the one that is irrational is that one. All right, so that is examples of rational and irrational numbers. You need to know the difference between those kinds of numbers.